All right, guys, this will be now the last video for this chapter. And also, guys, this will be the last video for this course. I'm going to now do 12.13 molar volume of gas. And I'm going to read the definition that is stated in your textbook. And when I solve the problems on this concept, I disagree with them on a molar volume, the way they calculate molar volume. So we'll do it the way it's supposed to be done. But they're going to be a different answer. The answer is no, but they're going to be different units, guys, when you calculate now the molar volume of a gas. Okay, so the definition is correct, guys, in the textbook. The molar volume of the gas is the volume occupied by 1 mole of a gas at a specific temperature and pressure. Now, so the molar volume is nothing else as the ratio between the volume of the gas to its number of moles. That would be the molar volume. And so when you have a certain volume of the gas divided by number of moles, you are going to get now the volume of the gas that is occupied by 1 mole, 1 mole of the gas. Okay, so that's what the molar volume is the ratio between the volume of the gas to its number of moles. Now, I'm going to now solve, guys, example here, 12.8. And so let's see what's given here. What is the molar volume of O2 gas at each of the following sets of pressure, temperature conditions? Okay, so this is what's given here, guys. It's given here pressure is equal to 1.20 atmosphere. By the way, I'm just going to solve, guys, one of the problems here because they're all redundant here. They're all pretty much the same. You just plug in and find the answer. And the temperature, guys, again, remember you got the Celsius here, 25 degrees Celsius. You always have to convert it into the degree of Kelvin. Don't forget. And so the question is, again, molar volume. In your textbook, you just find the V, but that's not really correct. And that's where my disagreement now with the textbook, the way it's supposed to be actually done. So the way I'm going to do it now is I'm going to find now the molar volume, which will be the ratio of V over N, and actually N is supposed to be 1 mole in here. But I'm going to use the PV-nRT to solve now for molar volume problem. Now, so all I have to do now to solve this problem is to find the volume based on the based now on the let me just real quick state now. So from here you can get now V over N is equal to now the R times T over the pressure. Okay, now here I can see in this problem here they assume now by definition N is equal to 1 mole. That is correct, but in many cases when you do solve these problems, they actually don't give you 1 mole of the gas. They give you a certain amount, and so once you find the volume of the gas, you will divide on whatever the volume they give you, and that will be V over N will give you that molar volume, guys, will be per 1 mole. Let me see if example 12.19 addresses this, and the answer is pretty much the same thing as the other one, just the difference is here you're given, guys, the temperature and the pressure. Here you're given just the actually also temperature and the pressure. So I am not, guys, going to bother even solving 12.19 because the same thing is 12.18. All right, so let's get to this. So, all right, so let me start plugging things in. And again, so what I'm gonna do, okay, let me just make sure that I'm actually I'm actually solving it. Let me just see. The book has a little confusing way, and I'm trying to actually incorporate the solution of the book to the correct way of solving this problem. All right, so let me do it. V is equal to here now, out of this ideal gas law, it's equal to nRT over the P. And so here we're going to use 1 mole of the gas. But generally, the way we solve again these problems, we get the volume, and this is more experimental, supposed to be problem. We get the volume, you measure the number of moles, and the ratio of V over N will give you guys the molar volume. So it should be really the units for the molar volume should be really liter over moles, guys. Okay, so let's do the way the book does so that I don't confuse you guys with this. So we're gonna plug now 1.00 mole because, you know, it has 1 mole of a substance, even though they don't really explicitly state this in the problem, but they now say by definition molar volume involves 1 mole of the gas, and so they just use this 1 mole times 0.08206 atmospheres times liter mole Kelvin. And then we're going to times it now the temperature, which is 298 Kelvin, 298 Kelvin. And I will divide, guys, now all of this by pressure, atmosphere. Now, so mole canceled out, atmosphere canceled out, Kelvin canceled out. So you're going to get liters now. But again, guys, when you have this kind of problems, molar volume, it is usually, guys, you through the experiment find the volume of the gas. You're going to find out the number of moles of the gas through the experiment, and then you take the V over that N to give you the molar volume, because when you divide the volume divided by a certain number of moles, the denominator always going to be 1 mole in here when you do that, and that will be a molar volume. In other words, 1 mole of the gas will occupy a certain volume. So that's why, I mean, usually when you have a calculation of molar volume, you're not really, you know, kind of go straight like this and just do it. But we'll do what the book does. It's okay. All you have to do now is, you know, plug in the numbers into your calculator to come up, guys, with the answer. All right, so let's do it. So it's going to be 0.08206 multiplied by 298. And then we'll divide it now by 1.20. So everywhere we got 3 significant figures here. So I got now 20.4 liters here is the final answer. And that's pretty much the way now to now handle this calculation, guys, of the molar volume here. Now, let me see. I want to see if there's any, you know, any other questions that are gonna pose you guys any difficulties here. And I don't see again any, they all solve the same way. PVNRT, you find the volume, you always, guys, have to put 1 mole in here. And again, I kind of disagree with the way they present this problem to you guys in this part of the chapter, because the molar volume really by definition is the ratio of volume of the gas divided by the number of moles of this gas. Okay, and again, this you usually get from the experiment. And this, guys, you also get from the experiment. And so when you plug now this and this, even let's say hypothetically you have a 0.043 liters of the gas, and corresponding, let's say, to 0.00932 moles, some hypothetical numbers. So that will be, when you do this divided by this, let me just do it to show you guys this is what you're gonna have actually as a real true molar volume of a gas. And again, this is not the same problem as this. I just want to show you guys how in the real laboratory settings you calculate the molar volumes. So there will be, let's say, 0.043 liters divided by 0.00932 moles. And then you're going to get, guys, something like this. You're going to get 4.6 liter per mole. And that will be implying, guys, here that you have 1 mole. And that will be your molar volume here. In other words, volume of the gas per 1 mole of the gas, okay? So again, this is an introductory course. That's why they try to keep it very simple here. And if this problem, guys, is given to you on the exam, just use the ideal gas equation like the book does. I'm not going to deviate from the book. Just plug in the 1 mole of the gas here and find out the volume. And then volume, guys, will represent 1 mole of the gas. So again, this is more like theoretical way of doing it, but the practical way, you really should find the volume of the gas from the experiment. You have to find, guys, the number of moles also from the experiment. There are experiments in the not 107, may not be 107 class. I have to check, guys, your manual. But in other chemistry courses, there are experiments that actually do this kind of calculations now. And if you interested in learning about this kind of experiment, just please let me know, and I will, guys, give you the link to definitely to one of the experiments that I know. And so this is the way, guys, how the book does the calculation of molar volume of the gas. So I'm going to now see what other, there are other examples that they want you guys to solve besides the one I just solved here. Let me just flip through the pages here real quick to see if I want to, if we need to solve some more. And there are, guys, there are now some more problems here. So I'm going to go ahead and also solve those. But what I see here on page 527 here is the standard temperature and standard pressure conditions. And I was going to mention it that the volume of different gases can be, I'm just reading what's written in the book here, compared only if the gases are at the same temperature and pressure. It is convenient to specify a particular temperature and pressure, and I'm going to the STP, to the standard temperature and pressure condition, which is considered to be temperature 273.15 Kelvin, and pressure is 1 atmosphere. And so standard temperature for gases 0 degrees Celsius, so 273.15 Kelvin, as I just stated. Instead of pressure is considered to be 1 atmosphere or 760 millimeters of mercury. Gases that are the standard temperature, standard pressure conditions are said to be at STP conditions. I already mentioned that. STP conditions for the gases are those of standard temperature and standard pressure. So, and here again, they actually here on page 528, they actually state correctly the molar volume of the ideal gas at STP. So on page here, page 528, so they calculate the molar volume here at STP, and so they calculated, guys, as 22.414 liters, which is correct. And again, guys, you can just the way to do it is pretty straightforward. And again, they use the mole from they use PV-nRT here, and then define the volume using the 1 mole here for the as molar, to calculate the molar volume here. So nRT over the P. So again, the way you do this, you're gonna state that 1.00 mole of any gas, supposed to be ideal gas though, times this 0.0206 atmospheres liter mole Kelvin, times now the temperature 273.15. We talked about it, guys. This is the standard temperature, and the pressure is, of course, 1 atmosphere in here. And so consider this to be exact number, guys. Don't limit this by the significant figures. So now when you do all of this, you're supposed to get now this molar volume here. And again, this is what's called the standard molar volume of a gas. That is 22.414 liters per 1 mole at STP, standard temperature pressure, which is 1 atmosphere, and temperature is 273.15. Now, they have this interesting example here, and I'm going to solve it. It's the last example, guys, that needs to be here solved. So let me just erase here. So I'm going to do now example 12.20. All right, let's see what's given here. Calculate the density of HCN which is of course a highly poisonous gas. This will, guys, kill you if you don't know how to operate or how to work in a lab. This is really toxic poisonous gas at each of the following sets of conditions. So we're going to solve just A in here because B will be solved in the same matter here. And so what's given here is the temperature here at Celsius. Okay, so again, we're going to convert it really quick to Kelvin, guys. Don't forget, 273 Kelvin. And so they're also giving us the pressure here, which is 2.00 atmospheres. All right, so so the way we can solve it, I can see they also have this formula here on the same page 528, that the density of the gas is the ratio of the molar mass to molar volume, right? Again, tricky. Let me just do this. Let me just actually state what the molar mass is so that we can see how this is the same thing as density. So the molar mass is the ratio of mass of the substance to its number of moles. And of course, the molar volume is V over N. You see, guys, remember how I was describing the molar volume correctly, V over N? And so when you now expressing it the correct way, as I try to do it here in this video, this is now going to make sense because N and N will cancel out. And what you're going to wind up is M over V. But M over V, guys, with no mass over volume is nothing else as a density. And so that's what makes sense, guys, the way I explain it without even seeing this example here, 1220. Okay, so that's now, let's now solve this problem here. So the way we want to solve it, we're going to use this formula here, that the molar mass of the substance, so I'm going to just state it in words, molar mass of a substance over the molar volume. And of course, I can use it now as molar mass is M over N over now V over N. And so to solve this problem now logically, what we need here is several things. So we can find out the molar mass of the substance. I just need identity HCN. So this is what's given HCN. So I can find the molar mass using the periodic table. And once I find the molar mass here, I'm going to plug it right here. And the next thing I need to do, guys, is to find out now, let me see what else is given here. I will need to figure it out, guys, now the volume here per 1 mole of the substance using the PV-nRT. So once I do this, once I've figured out this, the ratio, I can do the ratio, of course, here per 1 mole, but I just need the volume here based on this PV-nRT. I'm going to plug it in here for 1 mole. I'm going to get my density, guys, of the gas. All right. So let's do step by step here. So the molar mass will be, now I have to use the periodic table. So the H will be 1.008 grams per mole, plus C will be 12.01 gram per mole, plus nitrogen is 14.01 gram per mole. So I'm going to add all of these up to get now the molar mass. To solve it halfway, guys, now, so it's going to be 1.008 plus 12.01 plus 14.01. So I got here molar mass is 27.03 gram per mole. Okay, now the next thing I can do now is the way I always wanted to solve this problem. I want to solve it is V over N, which is the molar volume. And then so from here, the ideal gas law equation, it would be nothing is R times T over the pressure here. Again, all I did just brought this one down, and this one I brought down here, cross multiplying. So let me plug everything in here. So 0.08206 atmospheres times liter mole Kelvin times now the temperature, which is now 250 plus 273. Let me use my calculator just to make it fast. 250 plus 273. I got 523 Kelvin. I'm going to divide it now by the pressure, which is 2.00 atmospheres. Okay, here you go. And so there will be now the answer here. Let me just do the following, guys, in here. And also what I need to do here is, let me just find out now this ratio here. Okay, and what else I need to do here, guys, is I want to do this. And I want to make sure you guys understand that this N is, I know what it is just 1.00 mole here. Because remember, this is the molar volume. It's like molar mass. This is the mass of a substance per 1 mole, but this is now the volume of the substance per 1 mole of the substance here. And so let me just do all of these calculations to get you guys that volume per 1 mole. Okay, so that would be now 0.020206 times 523, and then divided by 2. And so what I got here, let me see significant figures. I got 3 here. I got here 21 points. I'm going to put 1 extra because it's an intermediate, guys, result in here. 4 little 6. And that would be, guys, now Kelvin cancels out. Now Kelvin cancels out now. And so let me see what else has to cancel out. Atmosphere cancel out. And so what I got here, liters, guys, per mole. And that's where you see my unit here per 1 mole already sitting and waiting here for me here. Okay, so that will be liters per mole. And you see how units, guys, are nicely here transferred right here. And again, I could just say 21.46 liters per mole. I don't have to put 1 in here. So let me actually erase it. I just put it here just for demonstration, but you do not have to put it here. Once you put a mole without anything in front of it, you imply, guys, that you do have now 1 mole in here. And so now the density simply will be now the molar mass, the ratio of the molar mass here, which is found, guys, using the periodic table here, is 27.03 grams per mole. Now divided by 21.46 now liters per mole, because remember, guys, we had the right units here. And so now look, mole and mole cancels out. But if you guys had done it with the using mole 1 times 1 mole in here as the textbook does, you will never have a mole, guys, now in the bottom here. And so that would not be, now with the units, guys, you will not be able to get some logic going in here to get now the final units for density is gram per liter, which is what the density of the gas is. We use gram per liter here, and now it's correct. And so all we have to do now, divide the molar mass by its molar volume, which is now 27.03. We're going to divide it now by 21.46. And I got here 3 significant figures. Let me just make sure that I do have 3 significant figures here. 3, 3. We're going to assume that this is a dot in here. Let me just go through everything here, guys. And let me just see. And I can see the textbook actually has a 3 significant correct. So I got now 1.26 here, 3 significant figures. That is correct. And I'm checking out the textbook. It's 1.26 gram per liter. So now this is all looks good. This all looks logical. Gram per liter will be actually the units of density. And again, I solved it the way it's supposed to be solved. It's a ratio of volume to the number of moles. And so my units, as you can see, guys, as a result, came out to be correct, liter per mole. I now took that number and I plugged it here in the formula that I stated before here, and which is stated, guys, in page 528. And so when I did this divided by this number now, the molar mass by the molar volume, I actually was able to cancel the moles in here, which I wouldn't have had if I had not made it the right way, so that I can get now the correct units for density, gram per liter, guys, grams per liter. So this is, guys, the end of the course. I covered, guys, everything that's supposed to be, guys, covered according to the syllabus. Oh, hold on a second. You know what? I can see now I have to also cover 12.14. My bad. I was actually going to prematurely, guys, finish the scores. So my apology. So in the next video, guys, I am going to now finish the scores. I'm going to cover now 12.14 to finish it. Now, what I also noticed that 12.15 now has the concept, actually 12.16 has the concept of Dalton's law of partial pressure, which is not part of the course. But last time, guys, when we had the Zoom live lecture, you actually, guys, had the lab on this concept, and you had a lot of questions on it, some of you guys. And so this is not actually the part of the course, the lab material. But during the Zoom lecture, guys, if you still have a question, questions on Dalton's law of partial pressure, which you use, guys, to determine the number of moles of hydrogen gas, you can always ask me, and I can go through this, even though it's not part of the syllabus. I will still cover it, guys, because you will need it for your lab. So again, I'll see you guys in the next video to cover 12.14, chemical calculations using molar volume. And so I'll see you guys in the next video.